Okay, here are the notes for Chapter 5, Section 3, which is still factoring, but we're factoring ax squared plus bx plus c. We're factoring this, and we're going to use grouping. So this is a little bit different, okay? So let's just start again by multiplying two binomials out. So 2x minus 1 times x plus 2. Okay, if I FOIL that out, first times first is 2x squared. Outside is 20x, inside is negative 1x, so I get positive 19x. My last is negative 10. Okay, so just like I was doing, if I was doing FOIL, let me just write them down. F was 2x squared, O was 20x, I was negative x, and L, your last, was negative 10. Now how did I get the 2x? More importantly, how did I get the 2, the 20, the 1, and the negative 10? Well, I got those by doing 2 times 1, or 2 times 10, or negative 1 times 1, or negative 1 times 10. So these follow patterns. What we learn is this right here, 2 times 10 gives me the 20, okay? And the negative 1 times 1, the inside gives me the negative 1, that gives me the 19. Okay, so we need the outside and inside term. Okay, well, so to get the outside and the inside term, you've got to break this up like so, just like if you had just written them out, plus 20x minus x minus 10. So the idea is, what do we have to do to figure out what these are? Okay, because that's not factors of negative 10 that add to 19. We cannot reverse, we cannot use factors of C to get B. That's not possible here. For the main reason is because A does not equal 1. So we cannot use factors of C to get B because A does not equal 1. So what are we going to do? I'm going to do this by just working an example to start with. Okay, so remember math, we really want to make sure everything equals and is equivalent and can be replaced with each other. So let's look at this problem. 2x squared plus 13x plus 15. Okay, I'm going to do this in a few different ways. I'm going to start by doing what A, B, and C are. So, for this problem, A is equal to 2, B is equal to 13, and C is equal to 15. Then I'm going to say, what does A times C equal? Well, that's 2 times 15, that's 30. Then I'm going to say, well, what are the factors of 30? What are the factors of 30, okay, that add to 13? So 1 and 30, 2 and 15, 3 and 10. Oh, that gets me real quick. I'm there at 3 and 10. Because 3 plus 10, right, 3 plus 10 is equal to 13. Right, if I add those, I get 13. Okay, so I've got that. So what I'm going to do is I'm going to take this expression up here, and I'm going to rewrite that as 2x squared plus 10x plus 3x plus 15, for the pure sole reason that 10x plus 3x is the same thing as 13x. Okay, now I've got 4 terms. 4 terms would indicate that we need to group. for terms usually means we group. Okay, so can I group? I think I can. I can do the 2x and the 10x, the 3x, and the 15. If I do that, and if I keep going, my next step would say I can pull out a 2x from the first thing and I get x plus 5. I can also pull out a 3 of the second part and I get x plus 5. And then together I've got an x plus 5 I can pull out, and that gives me 2x plus 3. I've now factored my original equation into two binomials that result in the original trinomial 2x squared plus 13x plus 15. If I forward that out, I will get that. So, how did I do it? Can we put down a process? I think we can. Okay, so we need to label our steps. So, let's label our steps. First thing I did was here. Then that was my second. That was my third step. This was my fourth step. And then the last little bit from here on out was my fifth step. All of that. So all of that, including that too, was my fifth step. Okay, so what were my steps? Okay, so step 1. Find A, B, and C. Step 2. Multiply A times C. Step 3. Factor AC to get factors that add to B. Okay, that was my third step. I found 3 and 10 on my problem. Fourth step is rewrite original with B split into factors found in step 3. Okay, and then once I do that, and everything else we've already covered, because that is just factor by grouping. Okay, so let's look at another example. Example 2. 6x squared minus 11x minus 10. So I came over here and I did some work. I particularly did A is equal to 6, B is equal to negative 11, C is equal to negative 10. AC then is 6 times negative 10, or negative 60. And I want factors of negative 60 that give me a negative 11. So I come in over here and I'm factoring 1 and 60, 2 and 30, 3 and 20, 4 and 15. That probably makes sense. It's correct. So we pick out 4 and 15, 4 and negative 15. So my next step was to go back to my original, right here, and I want to rewrite that as 6x squared plus 4x minus 15x minus 10. Now I'm at the point where I'm going to factor by grouping. So my groups are here and here. The addition in between them. I pull out a 2x to leave me with 3x plus 2. I pull out a negative 5 and I'm left with 3x plus 2. And then I get 2x minus 5 times 3x plus 2. All right, that's example 2. Let's do example 3. 3x squared minus 2x minus 4. Okay, so AC is equal to negative 12. Looking for factors of negative 12 that give me a negative 2. 1 and 12. Negative 12. 2 and negative 6. 3 and negative 4. Negative 3, positive 4. Well, and I could just keep going, right? 2, 3, 4, 4 times, yeah. So, and then I could switch the negatives to the other side. But these are all what I want, and there aren't any that work, and so I say that's non-factorable over the integers. Non-factorable over the integers. Okay, so again, we're at the point where I would ask you to do some problems on your own. So I'm going to write them down. Here's your U try. So after you get them copied down, pause this and give them a try and come back and check after you've given it a solid effort. 15x cubed plus 40x squared minus 80x. Okay, so pause it now. Come back, take a look at them after you've tried both problems. I'm going to work one first. Okay, look for GCF. There's no GCF. AC, 2 times negative 7 equals negative 14. So that's going to factor as 14 and negative 1. So I have 2a squared plus 14a minus 7. I have 2a, and I'm left with a plus 7, minus 1, a plus 7. So I get 2a minus 1, a plus 7. Okay, so that is that one. Remember, I grouped it like this. Okay, and then this term is the same. Those are the same terms, so I pulled them out, and I'm left with 2a minus 1. Let's do 2. Okay, is there a GCF? There is a GCF. My GCF is 5x, I believe. 5x, and I'm left with 3x squared plus 8x minus 16. 3 times negative 16 is negative 48. Factors of negative 48, that give me 8, or 12 and 4, 1 and negative 4. So I have a 5x. I also have a 3x squared plus 12x minus 4x minus 16, or 5x. I can pull a 3x out, and I'm left with x plus 4. And pull out a negative 4 out, and I'm left with x plus 4. And then I've got 5x, and then I've got x plus 4 times 3x minus 4. And that's that one. So just to talk it again, GCF. All right, GCF came out. Then I factored by grouping. Rewrote that from there. So on. Okay, let me know if you have questions.